So hi guys, I'm welcome and we will now basically going to solve in this video the third question of Harvard MIT Maths tournament which was held in spring 2021 session, particularly on 6th March of 2021. The third question is a pure algebraic question which is asking us that among all the polynomials px which have integer coefficients, and it is given to us that the value of the polynomial px at minus 10 is 145 and the value of this polynomial having integer coefficients at the value of 9 is 164. We need to find the smallest value of p0, or we just need to find the smallest value of the absolute value of the polynomial px at x is equal to 0. Okay, so here in this thing, actually this is a very easy question. Okay, this seems difficult because you must be thinking that only two data are given to you, that p minus 10 is 145, p9 is 164. You need to find p naught, but it is not the case. Actually this question is extremely easy. We just need to create a polynomial which will going to satisfy these two conditions, and then we will simply going to put 0 on it and find the answer. So this video should not go above 5 minutes. So here if we write the polynomial px, but first we need to find a pattern. Okay, first actually we need to find a pattern here. It has been said that p minus 10 is 145 and p9 is 164. There need to be a pattern, and the pattern is that when 145 is subtracted with minus 10, it will be the same as 164 subtracted with 9. Both of them equals to 155. So this is actually a pattern. So if I create a polynomial px which is in the form of a constant multiplied with x plus 10 into x minus 9 into another polynomial qx plus 155 plus x. Let us suppose that this is a polynomial. Okay, let us suppose that this is actually a polynomial. When you will going to put minus 10 here, this expression will going to become 10 minus 9 times of q of minus 10 plus 145. Okay, now this is minus 10 10, so they will going to cancel and this whole term will going to become 0 and your answer will going to come to 145, which is this only. Correct? So just like that, when you will going to put y in this expression, when you will basically going to put y in this expression, actually this is our required expression. Okay, this is our required expression with which we will basically going to work furthermore. So when we will basically going to put 9 in this expression, or we will basically going to replace x with 9, this will basically going to return us k multiplied with 9 plus 10 is 19, 9 minus 9 is 0, multiplied with q times 9 plus 155 plus 9 is actually what, 164, right? This will again going to become 0, and then simply this is also the same thing which has been given to us. So actually this is that type of polynomial which is satisfying these two conditions, and this polynomial must also have integer coefficients, because of which I have put a constant k outside which needs to be an integer. So our required polynomial and our desired polynomial and our satisfied polynomial is k times of x plus 10 into x minus 9 times of q x plus 155 plus x. Now when we will basically going to put 0 here, it will going to become k times of negative 90 times of q0 plus 155, or p0 is in the form of 155 minus 90 times of k times of q0. We need to find the smallest possible value of the absolute of p naught. Now the absolute of P naught can be expressed as absolute of 155 minus 90 times of something as K into Q of 0. Oh no, this is ridiculous actually. I don't know anything here. Let us suppose this whole thing to be P. Okay, let us suppose this whole thing to be P, then P naught, or let us suppose another variable we will going to take. Let us suppose this to be Q, because this is P only, so you will going to get confused. So we can write then P at the value 0 and its absolute value will be 155 minus 90 times of Q. Now when you will going to plot a graph regarding this function which has been given to us in the terms of this variable Q, the minimum possible value which you will basically going to get here, we need to calculate that. Okay, it is eventual that this needs to be a positive number, and I don't know what thing Q needs to have inside himself. It also needs to have an integer coefficient, and K can also be non-negative. So Q needs to be an integer. Q needs to be an integer. It has been said that it will going to be an integer. It will going to be an integer. Can Q be 0? No, Q cannot be 0 because Q0 cannot be 0 first of all. Secondly, yeah, so it can be 1. So smallest value will be obtained at 1. It can be at 2 and 3 and 4. Okay, so in this case the possible value of P naught will simply going to be we can also try 0. Okay, because if we will going to put negative values in Q, the value for P naught will going to increase instead of decreasing, because negative will going to cancel each other out and this thing will going to add up. But we need to find the smallest value, so that's why I'm taking the positive value in order to make it subtracted from 155. Okay, so at 0 the answer will simply going to be 155. At 1 the answer will basically going to get 65. At 2 means at 180. 155 negative 180, it is simply 25. I do think so. 165, 175, 180, right. When Q is 3 means 155 negative 270, it will going to be right like it is 6, it is 10, it is 5, 6, 5, 1, 1. So it will simply going to be 115 and so on. So from here it will going to increase, and from here it has also started increasing because this has dominantly taken over 155. So the smallest value of P naught which you can get is 25. So 25 is the answer for this question. Such an easy question in Harvard MIT Maths Tournament. But it was not easy because to understand how to create a function with the given data is tough, but I have made a way for you. So whenever this type of question arises, you just need to create the function in order to find a pattern in the values being given to you as a data. You need to create a function in this form, then you need to put the value of x in whatever the numerical values it needs for you to solve for. Then you can simply do all the fucking mathematics and can evaluate the answer with the given set of conditions being provided to you in the question. So that was it. Again, we're going to see you later in the fourth question. And the fourth question of this test is actually the question for which Harvard and MIT are known for. Its difficulty. So, going to see you there. Bye. Oh no, this video has also been more than 5 minutes. I was wrong. I'm sorry.